All right, so we have a right triangle with an interior angle of pi over 3 and a hypotenuse length of 43.5. So we want to figure out this length here, which is opposite to pi over 3, and then this length, which is adjacent. So I'm going to create a trig statement. I know that the sine function utilizes opposite over hypotenuse, so I could create this statement saying sine of pi over 3 is equal to the opposite length over the hypotenuse, which is 43.5. And from here, if I multiply both sides by 43.5, then on the right-hand side, those will cancel out, and we get that the opposite length is equal to 43.5 times sine of pi over 3. So I'm going to go ahead and turn on my calculator and make sure that my calculator is in radians. And now I do 43.5 times sine of pi divided by 3. So that's 37.7. I'll round it to one decimal place since the 43.5 is rounded to one decimal place. So the opposite length is 37.7. And now we want to figure out the adjacent side length. And remember that there's two ways that we can go about doing this. We can use the Pythagorean theorem, or we could create another trig function. So the one that uses the adjacent and the hypotenuse, if we think of SOHCAHTOA, would be cosine. So we'd say cosine of pi over 3 is equal to the adjacent over the hypotenuse, which is 43.5. And just like we did previously, if I multiply both sides by 43.5, then we would get that the adjacent length is equal to 43.5 times cosine of pi over 3. And cosine of pi over 3 is one of our special angles, so we should be able to calculate that without a calculator, and this ends up being 43.5 times 1/2. And so we get 43.5 divided by 2, and that gives us 21.75. So now we know all of the side lengths. I'll just go ahead and highlight those. And we know 2 out of the 3 angles. So now we just need to solve for this last angle here. And the way that we can do that is by using the fact that the sum of the angles needs to be 180 degrees or pi radians. And so I know that 90 degrees is the same as pi over 2. So I have pi over 2 plus pi over 3. If I find a common denominator, that is going to be 3 pi over 6 plus 2 pi over 6, which is equal to 5 pi over 6. And I know that all of the angles need to add up to pi radians because that's equivalent to 180 degrees. And so if I did pi minus 5 pi over 6, that would give me pi over 6. So I know that this angle here is pi over 6 radians, which is equivalent to 30 degrees. So we have gone ahead now and solved this triangle by finding all of its angles and all of its side lengths. The ability to solve right triangles by using the trigonometric ratios is fundamental to many problems in navigation, surveying, astronomy, and the measurement of distances. The applications we consider in this section always involve right triangles, but soon we will see that trig is also useful in solving triangles that are not right triangles. Example 6 says, when the moon is exactly half full, the Earth, moon, and sun form a right angle. So that right angle is right there. At that time, the angle formed by the sun, earth, and moon is measured to be 89.85 degrees. So the sun, earth, and moon in that order create this angle, and this is 89.85 degrees. If the distance from the earth to the moon is 240,000 miles, estimate the distance from the earth to the sun. So earth to the sun is this, and we don't know what that is, but we do know that is the hypotenuse. And if we're on Earth here and we're associated with that angle, then this would be the opposite length, and the 240,000 would be the adjacent length. So we know the adjacent length, which is A, and we are trying to solve for the hypotenuse. So in our mnemonic device, the trig function that goes with that is cosine, because it's SOHCAHTOA. So the trig function that we are going to make now says cosine of 89.85 degrees is equal to the adjacent length, which is 240,000, divided by the hypotenuse. I'm just going to call that h. And if we solve this equation for h, we end up getting 240,000 divided by cosine of 89.85 degrees. And now that is something we can throw into our calculator. I just want to make sure that my calculator is in degrees, which it is. So now I can type in 240,000 divided by cosine of 89.85. So under these circumstances, the Earth is approximately 91,673,351.94 miles away from the sun. And that completes this example. Something that you will want to note for the homework is you want to know the difference between angle of elevation and angle of depression. So when you're looking at the horizontal, we kind of think of that as 0 degrees. And the angle of elevation is when you are going upwards from the horizontal, and the angle of depression is when you are going downwards from the horizontal. And this will help you when you are solving some of our homework questions.